Okay, so let's get started with Coral Reef Lecture. This hopefully is what we've been building up towards with all of the information we've discussed so far, to now actually start talking about coral reefs and the nature of the reef, the makeup of the reef, and how reefs form. Okay, so corals belong to phylum Cnidaria. The reason why they go into this phylum is all corals have a structure called a cnidocyte. We're going to call this the little gun. This is the gun that will shoot out little projectiles. The projectiles are known as nematocysts. Those are going to be our bullets. Okay, the nematocysts are the things that cause the pain. They sting, they harpoon, they entangle. Scientists have recognized over 20 varieties of nematocysts out there. But that's a common theme across all corals, is that they have nematocysts because they're in phylum Cnidaria. Now corals drop further down into the class Anthozoa because of the other key features and the structures that we want to look at that are associated with the members of Anthozoa. Okay, so now with Anthozoa, when we talk about corals, the polyp secretes, get this out of here, a skeleton of calcium carbonate. All right, that's a key feature for a lot of corals, not all. There are what we call soft corals that do not build calcium carbonate skeletons. But most of the corals we're going to look at when we talk about reef structure secrete this calcium carbonate skeleton. That's what turns into that hard, stony-like structure. This is the basis of limestone. So if you have limestone, gravel, that's old coral. That's coral skeletons. That was formed millions and millions, hundreds of millions of years ago. All right, looking at most reef-building corals, a lot of them, by and large, most all of them are colonial, where all the polyps are connected. They started as a single polyp and then divide asexually and produce another polyp and another and another and another. And they share this big basic body plan. They're all connected with this tissue that allows them to actually cover the surface of the calcium carbonate skeleton. As coral dies, new ones grow on top of the old skeleton, and this is what causes corals to enlarge. Alright, so as we look at corals, the basic coral types we're going to look at, or the basic type of coral, is this thing called a hermatypic coral. These are your basic reef builders. Alright, most of these contain that thing we talked about before called zooxanthellae. Alright, those zooxanthellae, those are the photosynthetic algae that will live inside the tissue of the corals. So if you look at the coral to the right over here, and you take a look at the polyp there, okay, so here's the general polyp. All these little dots in here, dot, 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 all those little dots, those are the zooxanthellae. Okay, now the zooxanthellae are what usually give coral their color. That's where we get the various colors of the corals. And when we're looking at these hermatypic corals, these are typically found in tropical waters because they are warm, shallow, and when we say shallow, that can be 100, 150 feet, and typically nutrient poor, meaning there's not a lot of phytoplankton, not a lot of food in the water, which is why the corals need the zooxanthellae, because the zooxanthellae is what primarily feeds the coral. So there's got to be lots of sunlight for most corals, the reefs we're talking about, to form. All right, so now, again, looking at the nutrition of the coral, the zooxanthellae is going to be responsible for producing organic matter. matter through photosynthesis, and that's what feeds the coral. They also will help produce the calcium carbonate skeleton. So the zooxanthellae is going to help with the production of that as well. Now the polyps, the coral polyps, those guys, what they're responsible for is actually capturing food. Again, remember the polyps capture the plankton. They grab it, whatever they can get a hold of with those little stinging tentacles, the cnidocytes and the nematocysts. That's where they're getting their energy. Now, energy distribution, polyps, about 3% of the energy for the coral comes from their polyps. The photosynthesis, about 97%. So you don't do well if you don't have zooxanthellae when you're a coral. Now, corals will have one other option of feeding. They have these filaments in their stomach called mesenteric filaments that enable them to get food. So they actually extend these filaments out of their body, and they use that to capture food that's outside. So if you look at the coral down at the bottom here, that is the mesenteric filaments that are being extended out. So these little stringy things here getting shot out, and that's sometimes the corals feed with that. A lot of times though, those filaments secrete digestive enzymes, so sometimes they use it to fight, and we'll talk about this in a little later lecture. But right here we're seeing it's feeding upon stuff with those mesenteric filaments. Okay, so again, that's not a lot of energy coming into the coral through the mesenteric filaments. So, again, better have your zooxanthellae. So, all right, now reproduction. Reproduction in corals happens in two ways. Asexual, simply growth of a colony from an original polyp. The polyp settles, and then it divides asexually over and over and over, and the coral gets larger. So that happens quite often. Sexual reproduction is broadcast spawning. Eggs and sperm into the water column. And hopefully fertilization takes place. And then that little planula that will form will drift around in the water. It'll move, it'll drift, and eventually it'll settle. The key is it needs to settle on a hard substrate in order for it to develop. If you don't have a hard substrate, you're not developing your reef. So, okay, so that brings us right into conditions for growth of reef-building corals. So the first condition is you better have a hard substrate. For that polyp to settle on. If you don't have a hard substrate, you can't start the polyp. And then, do you have enough sunlight for the zooxanthellae? Because they're running photosynthesis. Without enough sunlight, if the water's too cloudy or it's too deep, zooxanthellae can't perform photosynthesis. Corals have this narrow range of temperatures. They have a narrow range of salinity. They have a very low tolerance for what we call turbidity in the water. Turbidity or sediment. there's too much sediment floating in the water, it makes it cloudy and the corals can't photosynthesize. And low pollution levels. Okay, so corals are fairly sensitive animals. For those reefs to form, you better have some pretty good water conditions. So if they get out of these ranges, corals do not do well, and that creates problems. All right, so the temperature-wise, when we're looking at coral reproduction, they can only reproduce between 20 degrees Celsius and about 20 degrees Celsius which is going to be 68 Fahrenheit. Oh, that's not supposed to be there. Let me try to clean this up for you guys. Make this a little smaller, easier. Okay, so 20 degrees Celsius or 68 Fahrenheit to roughly 30 to 35 Celsius, which would fall between about 86 and 95 on the Fahrenheit scale. Okay, so that's their temperature range. Outside of that range, then you got stress on the coral. If corals get stressed, this leads to bleaching. Yeah, I'm putting in caps because I want you guys to really pay attention to this. Stress leads to bleaching. When they bleach, the zooxanthellae leave the coral. So you're losing 97% of your nutritional intake, your nutritional production when your zooxanthellae leave. That is not a good thing for corals to have happen. Okay, so if it's short term, corals can recover. Long term, corals bleach, they die. So, alright, temperature range. Other features. Ideally away from rivers. Away from the mouth of a river because of the influx of fresh water that causes change in water quality and the sediment. It can also flush pollution in there. It can stir up all the sediment issues we were talking about before and basically destroy water clarity. So all these things contribute to problems with corals or lack of corals. Algae. Algae is another big issue, and we'll explore this more as we get into additional lectures, but they don't like algae. Algae overgrows coral and can smother it and outcompete it for sunlight. Or if algae is already growing, corals cannot get a foothold and they can't actually establish themselves and continue to grow. So what corals have done is over their evolution, they have actually evolved different growth patterns and growth forms. What we tend to see, not a guaranteed rule, but a general rule, the taller, more branching colonies tend to be in shallow waters. Okay, because if you're in shallow water, I want to shoot up, I want to get tall, and I want to outcompete everybody around me. So you look at the coral, let me get the pen going. You look at the coral down here, this is elkhorn. So elkhorn grows up like this and out and gets big and tall, and these things can be 6, 7, 8 feet tall. And what they're doing is basically shading out all the other corals that might be growing down here. They're trying to compete against them. The flatter forms tend to be more common in the deeper areas. So when you're way down, you're 80, 100, 120 feet, and you're looking at these corals, they tend to get broad and massive and these big, big flattened forms. And it's thought the reason they get that big is to maximize the light levels that they get that deep down within the reef. Okay, so we've talked a bit about corals. In our next lecture, we're going to talk more about the types of coral growth forms. We'll get into these a little more and explore other organisms that are important to reef building.